make sure you go for your course, okay? In your course, to the left-hand side, in your blackboard, you will have something called Review CLO1. But as I see, everyone start to solve the question without having the knowledge, right? So let's go and have the knowledge in CLO1, right? So in CLO1, what we have, so what we are going to share together now, right? You see my board and you hear me, right? Those in the teams, they hear me as well? Okay, fine. Let's go and start the knowledge in CLO1. Later on, I'm sure you can solve the question alone, right? Let's go and remember what we have in CLO1 in our course, Education, Edu 1123, and also LSM 1123, right? The same for CLO1, right? These two courses, okay? Now, let's go bit by bit. What we have first, we have the number set. We have a number set. We call this one, okay, we call it what? Let's go and see. If you have this number, 1, 2, 3, 4, etc., we denote it by n because this is the natural number. This is what? Natural number. Okay, this is a natural number set. If you add 0 to the natural number set, you call it what? Yes, whole number. Whole number sets, okay? If you have positive and negative, so this is, yes, you denote it by z and call it integer, right? Okay, and the bigger one is called numerator over denominator, بسطنا مقام, and b, q are an integers such that q never be 0, the denominator will never be 0 because I cannot divide it by 0, right? We call it q. Why is q? You said rational number. Yes, it is rational number, and the other name is quotient, right? Quotient, right? Okay. So as you see, the natural number is part n is a subset of w, and w is a subset of z, and z is a subset of q, right? So it is fair enough. Any natural number will be rational. Any whole number will be rational. Any integer will be rational, right? Okay, so how to distinguish between rational and irrational? This is very important. Okay. How to distinguish between rational and irrational for you? As I said, if you have any natural will be rational, any whole will be rational, any integer will be rational. So this rational, b over q, we call it fraction. We call it what? Fraction. You have two types of fraction, right? One of them, we call it proper fraction, proper. And the other one, we call it what? Improper fraction, improper. When you call the fraction proper, if you have denominator less than the denominator, okay? So this is proper. Only this? No. If you have no common factor between the numerator and denominator, ما عندكش أي قاسم مشترك بين البسط والمقام. Improper fraction, yes, if I write 4 over 14, which is equivalent to this fraction, okay? 2 over 7 is equivalent or equal to 4 over 14. How to check this is equivalent or not? Just cross this one. So you will say 2 times 14 the same as 7 times 4. This is why these two fractions are equal, right? Or equivalent. But this one is improper, but the original one is proper, right? Both of them having numerator less than the denominator. هما الاثنين فيهم البسط أقل منين؟ من المقام. Okay, what about this one? If I write 7 over 2. 7 over 2, we call it mixed fraction, right? Because this one can write it 3 half. 3 and half. So 3 is an integer, half is a proper fraction. So this is mixed. Okay. Now we know how to distinguish between fraction or rational. Okay. Proper fraction, improper fraction. Okay. And the mixed number. And we know this one. We have some values. We cannot say equal. What we call it, yes. We call it irrational. We call it what? Irrational. Can you give me example for this irrational? Because we don't know all of them. By, you cannot say equal. You write it approximately 3.141, blah, blah, blah. If you stop at 2 decimal place, 3 decimal places, this is the 3 decimal place. But you can carry on, right? And for sure, you cannot use equal. You use approximate. We call this one approximate. Okay. Also, E is roughly 2.71 if you stop at 2 decimal place. Root square 2, you cannot say equal. You say approximately 1.41 if you stop at 2 decimal places. And root square 3 is equal roughly equal 1 point. So you can carry on. But for sure, root square, if you write like this is equal to -4. This is equal to -4 over 1. So when you use your calculator and you have no decimal, this is rational. But if you have root square 21 and you use your calculator, it give you 4.5, blah, blah, blah. Once you have this decimal, it means this is irrational. So distinguish the roots. Not every root is irrational. The root, when you calculate it by the calculator and have a decimal part, you call it irrational, right? But if it has no decimal part, so you call it rational. Okay? This is how to distinguish between rational and irrational. But if you see any number with by or e, okay, straightforward, you say irrational. Catch it? Okay. Now we finish the number set. Let's go for the Venn diagram. Venn diagram. Venn is a man representing a set in any closed curve. You can write it like this, in a triangle, rectangle, whatever, but you write your element here. This is one of the method of representing the set. So I can represent this set by the Venn diagram, or by another way, they call it roster. What does it mean? If I have X, Y, Osama, because any object, any collection of objects is a set. So I can write this one, instead of representing in the Venn diagram, I can write it X, Y, Osama. This is the roster way, right? Okay. But if you have an infinite number of elements, right? Like a natural number is 1, 2, 3, up to infinity, right? You cannot write all of them. Either you make dots to the right, okay? So, or leave it like this. So, or you can write X such that X is a natural number. Okay? Okay, so we know how to represent a set using the Venn diagram or the roster, or there is another way, they call it when you have inequality, X is an integer and X between -2 and 2, for example, right? So how to write this one? This is, they call it Can you mute your sound, please?
Red. All right. So if your favorite color is red, we're going to.
Okay. So in this case, I forget the name of this one. Okay. Yeah, set builder notation. This is the set builder. Set builder. So the set, you can write it as a set builder when you have inequality inside. This one, I can write it in roster by mentioning the number inside, okay? So I have -2, -1, 0, 1, 2, right? Because I have equal here. So -2 is included and I have 2 here, 2 included. So you can write the set in the set builder notation, or you can write it in the roster way, or you can write it in the Venn diagram. So you can represent the values here. So this is a Venn diagram. So you have 3 types of representing a set, okay? Now let's go for the operation in the set, or set operation. We have some operation in the set like A or and B, okay? Or this is or, this is and, sometimes they call it union, okay? So if I have A and B and they have something in common, A and B is the common area, right? This is A and B, right? So let's speak. This is A and B. But if you have B inside A, or B is a subset of A, B is smaller than A, okay? You can write B as a subset of A, right? This is, we call it subset, this notation. In this case, no, A and B, what is in common between them is the small one, right? Let's go for or union. If you have A like this and B like this, so you take everything, but don't repeat, right? Because you have something in common here. If you write it once, don't repeat it, right? Okay, so this is what we know. But in this case, if you have B inside A or B will give you the bigger one, right? Also in the AND, you have special case. If A and B are disjoint, there is nothing in common between them. So A and B has nothing. So I don't like to use this one. I'm just replace it by phi. So phi is the empty set. Okay. This is exactly and or, and we have another one. We call it what? We call it, yes, subtraction. So we have something called the universal set. Universal set. What is the universal set? Is a so huge one. Any set inside this universal set, right? So if you subtract the universal set, subtract from the universal set the set A, you have something called A dash, or the complement of A. The complement of A, right? What is the complement? Where is the complement of A? The element is not included in A, right? So this is the A complement here, right? What about if I would like to write B complement? B complement is also the universal set minus B, right? Okay. Now, to subtract, it means you take the element of A out of U, and what is left is the complement of E, right? Now, what is the property of this complement, right? Do you have any common element between A and A complement? No, because I take the element outside A, right? So there is nothing in common, so I have the empty set. If I'm going to have the or A dash, or the union of both of them, if I take A and outside A, I will get the universal set, okay? This is exactly the property, the main property of the complement, right? Okay. I'll just check if we have something I have to admit. It's okay already. Okay. Now we finished the first part of the set numbers, and Maha, do you have any question?
مستر سوري بس لما حليت السيلف تشيك يالي سؤال ان هل حرف ناقص
Okay, just wait. Just wait. I will go. I think there is a mistake in one question. I'll just show it to you. Okay, don't worry. Now we finished the set, number set, and the operation. After this one, what we have later on, we start with something called, yes, factorize number, prime number. So what is a prime number? A prime number is a number which is divisible by itself and 1 only, and or the prime number is bigger than 1. So we start the first prime number is 2, the 3. Don't take 4 because 4 is divisible by itself and 1 and 2 as well. And we said the prime number is divisible by itself and the 1. So the next prime number is 5, 7, 11, 13, and you can carry on. Any number is divisible by itself and 1, it will be a prime number. This using the prime number to do something called the tree method of prime factorization. Prime power factorization, okay? Factorization. How to find the prime power factorization for this number, 675? You have to check if it is even number divided by 2. But this is not even, so I cannot divide it by the first prime number. But I have to go for the next prime number, 3. How to know that your number is divisible by 3? Just adding this one together. So I have 18. 18 is divisible by 3. Okay, so I can divide it by 3. Divided by 3, what do you have? Yes, 2, 2, 5. This is not even number, but I can check it is divisible by the 3 or not. It is divisible by 3. So divided by 3 again, you will have 75. This is not even number, so I cannot divide it by 2. I'll go for checking by 3. If the summation of the digits are divisible by 3, your number will be divisible by 3. So I divided by 3. I have 25. This 25 is not even, but cannot be divided by 3. So I'll try the next prime, 5. So it's a 5 and 5. Now, the prime power for this one is exactly how many 3? I have 3 twice, so I have 3 to the power 2. How many 5? Sorry, 3 to the power 3. I'm sorry, because I have 1, 2, 3. How many 5? 1, 2. So 5 to the power 2. This is the prime power factorization for it. Some people don't like to do this one. So it's easy, sir, to have it like this. 6, 7, 5, and they divide it by the first prime. 2 is not working, so I try the 3 when I know this number is divisible by 3. And this is also by 3. This is also by 3. This cannot be divided by 2 or 3 yet. Try 5, 5, 5, 1. Okay, it's up to you. But this we call it the tree method. This is what we call it, the tree method, which is the equivalent to this one, right? Now you know how many 3 you have easily and how many 2. So you write the prime power factorization for this one, right? If I am asking you to have the prime power factorization for 150, I will do it in this way: 275, 3, 25, 5, 5, 5, 1. So 150 can be written as 2 to the power 1 times 3 to the power 1 times 5 to the power 2. This is 150, okay? So I know the prime power factorization for these two numbers. If I know these two one, I can find something called the greatest common factor, GCF. So GCF, G for greatest, C for common, F for factor. So the greatest common factor for 6, 675 and 150. To find the greatest common factor, go for the common basic. 2 is not in 675, so it is not common, but 3 is a common base. But in the GCF, I take the lowest power. So I will take this one from here. And 5 to the power 2, 5 to the power 2, both of them are the same. So I have 5 to the power 2, right? So the greatest common factor will be 75, right? You have something else called, yes, I hear you saying, the LCM. What is the LCM? LCM, I know C for common, M for multiplication, but L for the least common multiplication. In this case, for 675 and 150, how to find it? Yeah, this is, in this case, you go for the common base, which is 3, but you take in the LCM, you take the highest power. So I take 3 to the power 3 at this case. 5, they have the same, so it doesn't matter, I take each one. In LCM, even the non-common, you take it, okay? So I have only 2 non-common, so I'll take 2. So how much it will be? Can you give me the number for this one, please? Hello? Can you give me the value of this one, please? I think maybe someone write in the chat. Okay. Okay. I cannot see. How much is it? 1,000? Yes. What is the number? Okay. Doesn't matter. Just
1,350.
Yes, sir. It's 1,350.
excellent. Okay. Why I put this comma here? This comma, when you have from right to left 3-digit, you write something called, we call it punctuation, right? We call it what? Punctuation. Okay. This is how to write the check. Every 3-digit from the right, you put comma. And you can write it in words, 1,350. Okay, this is also in CLO1. Now, what do you notice? You notice the LCM is bigger than LCM for X, say. And why? LCM for any 2 number, say 675 and 150, is bigger than any one of them, bigger than 675 and also bigger than 150. But the greatest common factor for this two, the same number, is less than or equal any one of them, right? So if you have multiple choice, you can exclude the wrong answer, right? So if you are asked about LCM, any value less than the 2 numbers or the 3 numbers you are given will never be the right answer for the LCM. Any value greater than the 2 number or 3 numbers you are going for the greatest common factor, greater than these numbers will never be greatest common factor, right? This is very important notes. Now I know how to get the least common factor and the greatest common factor using the tree method, right? Now I'll go with what? I finish this one. Yeah, I'll go for the ratio, right? Ratio or proportion, right? Proportion. Okay. Ratio, you can write a ratio or proportion like this, x to y. This, when you have the word 2, it means you have proportion. You can write like this or x over y, fine. If I say the female to male students are 1, 2, 3. So I can write it 1 up to 3, right? Or you can write it 1/3. You can write it 1/3. But you have to know what is 1 for. 1 for the female and 3 for the male, right? If you are given the number of male, say I've given you the number of male 675, and ask you about the number of the female, right? So you can multiply this one, and you have x equal to 675 times 1/3. How much is it? 225, right? So I have 2225 female students, right? Okay, if I'm just comparing Ras Al Khaimah, right, campus, to Sharjah campus, okay, to Dubai campus, or Abu Dhabi campus, any, all right? I say this is exactly 1 to 2 to 3, right? If I know the number of students in any campus of this one, I can get the rest of this one. Say I know the Sharjah. In Sharjah, they have 1,700 students, right? And I ask you, how many students in Dubai? Okay, so what you are going to do, you just say, call it D. So in Dubai will be 3 times 700 over 2. And how much is it? 2,450. Is it correct? Okay. Now, how to find the number of students in Ras Al Khaimah? Yes, it is easy. I have Ras Al Khaimah, I call it R, for example. Yes, because this is already known, so I can know this one. So Ras Al Khaimah students will be, 1 times 1,700 over 2. So I have 850 students in Ras Al Khaimah. Okay. This is when you going to use a proportion or the ratio, right? Especially use this one in the map. If you have a map and you're waiting for Talaba delivery, right? You just keep looking for your mobile, okay? And this is your location. This is your location, delivery location. And you have this delivery man is coming straight for him. This is delivery. For sure, the distance in the map will never be as the distance in the real distance, okay? So each 1 centimeter in the map in proportion to the real distance will be, say, 3 times 10 to the power 8. This is exactly the scientific notation, if you remember. This is equivalent to 3 and 80 over here. So how to write 80? As I said, from the right, for each 3-digit, you write the punctuation, okay? Okay, you can write it at 300 million in words, right? Okay, now, if you know the real distance, or you check in your map and find he's in 2 centimeter in the map, right? Or 3 centimeter, whatever, 2 centimeter in the map. Can you find the real distance? Yes, I just use this one to have x will equal to, 3 10 to the power 8 divided by 2. So it will be 1.5 times 10 to the power 8 centimeter. If you would like to change this one into meter, you divide it by 800. So divided by, 100, you will get it into meter, right? So it will be 1.5 times 10 to the power 6. I lost 2 0 because I divided by. So this is in meter. If you would like to have it in kilometer, you divide it by 10 to the power 3, right? So this one will be 10 to the power 3, 1.5. Okay, so it will be 1.5 kilometer. This is the exact use or the practical use of the ratio and proportion, right? What's left? We have something called algebraic model, right? Algebraic model. What does it mean, algebraic model? It means the equation or expression, mathematical expression for you. But there are some keywords. If I'm saying numbers, And after this number, I said more than or older than than XA. So in this case, you have to add this number into X. So you have X plus this number, right? This, what does it mean? But the opposite side, you subtract this number. If you said less than or younger than, okay, X. So in this case, you subtract X, this number from X. This is exactly when you have discount, you subtract the discount, right? But in this case, if you have a charge, you have to add the charge, right, to the cost, right? Charge, you add this one charge, right? And older or more than, sometimes they call it exceed, right? So the same word. This is the keywords you have to catch. The main one is the word per hours, right? So 5 dirham per hour. So you write 5 times the number of hours, right? So the word per. But the word is, it means you have a result. This is equivalent to equal, okay? So you can write the algebraic expression using these keywords. This is very important for you. Can you remind me if you missed something in the CLO1? We didn't cover it. Now, if we covered everything, we can go to the our CLO revision. In your portal, please open your portal right now. I have it here. I go to the left-hand side here. I don't know for LSM 1123, where is the writing this one, but in my course, EDU1123, it is in the left-hand side, you have review CLO1, right? So click on review CLO1. And now we can start the quiz. Please do it with me. Okay. And press begin. Now, let's go for this one. The scale, I like writing in a way because you will be given a formula sheet of, I don't know if they have the formula sheet or not. I'm trying to adapt my scratch paper to write this one. Okay, you are given this one. In a scale drawing, this is what I said, of a mapping, 1 centimeter represent 4 inch, right? So 1 centimeter, yeah, this is very important. 1 centimeter represent 4 inch, right? Okay. The highest of the real painting, the height of the real painting is 60 inch. 60 inch, right? What is the height of the painting in the scale of drawing? You draw in terms of centimeter, but the distance, real distance, up to what? Up to the inch, right? So he's asking for this one, okay? How you can find this one? Yes, just make the cross product. So X will be 60 times 1 over 4. So it will be 15. 15 what? Yeah, the missing, this is a painting. This is the real painting. Okay, so this will be, he's asking for what is the height of the painting in the scale of drawing. The scale of drawing, 1 centimeter for 4 inch. This is what I have done with the delivery man, right? So now you can find what is the right answer. Is 15 centimeter, which is fair enough. Without going through this one, it's easy to check. It will be never bigger than the one in the real distance, right? Okay, so 4 inch, 1 centimeter. So 60 inch will be 15 centimeter in the painting, right? But how to do it properly? You do it using the proportion, right? So now let's go for the next one. Here, yes, write the set below in the roster. Roster, it means you have to write the number, what inside this one, right? This is what I just said, right? X greater than or equal to -3. In the real line here, greater than or equal to -3, it should be like this. Bigger than, you go to the right, right? So what is the number here? You can write it as in the roster -3, -2, -1, 0, 1, and dots like this. What is the right answer? Yeah, the last one, right? Okay. Now I'll go for the third question. How to find the greatest common factor? I think now you can do it yourself. You take 7, 6, 5, and you make it. This is the easy way. It is not even numbers, so you divisible by 3 because the sum of the digit 7 plus 6, 13 plus 5, 18. 18 is divisible by 3, so I can divide it by 3. This is 2, this is 5, this is 5. This is divisible by 3, yes, because 2 plus 5 plus 5 is 12, so I can divide it again by 3, 75. This is also divided by 3, 25. This is not divisible by 3. It's divisible only by the next prime 5, 5, 5, 1. So I can write this number as 3 to the power 3 and 5 to the power 2. So 3 to the power 3 times 5 to the power 2. Now I'll go for the second number. Okay. The second number is what? 72. I'll go for the 72 and do the same. This is even number out here. I'm lucky. I can divide it by 2. I have 36. This is also even number. I can divide it by 2. Also even number I can divide. Now this is not even number, but it's divisible by 3 only. Now I can write this 72 in terms of power, prime power, 2 to the power 3 times 3 to the power 2. In the greatest common factor, between these two numbers, 765 and 72, as I'm looking for the common. 2 is not common base, but, 3 is a common base, right? In the greatest common factor, I take the lowest power, right? So I will take 3 to the power what? 2. So 9 is the greatest common factor, correct? Check. Now I'll go for the LCM. LCM, in this case, I take with the highest power. So 3 is in common, but I will not take this one. I will take this one with the LCM, 3 to the power 3. 5 is not uncommon, 2 is not common. I should take them also. يبقى في الجريتس كومن فاكتور باخد اللوست باور من الكومن. اما في ال LCM باخد الهايست باور من الكومن وباخد النون كومن اللي مشتركين واللي مش مشتركين. 5 to the power 2 times 2 to the power 3. What is this number? Can you give me this number, please? Hello, guys. Anyway, in the exam, you are lucky because you have numbers to choose, right? So which one of these?
36.
Mister, it will be 2,700.
Yeah, you are right. 2,000?
Yeah, 2,700.
700. Do we have this one in our choice here? We don't have, right?
I accidentally.
No problem. That's no problem. Do whatever you like here. Make a mistake, we correct it. Next week, inshallah, in the exam, you will not have it, right?
Yeah.
Yeah. What's that? Yeah, don't worry. You are learning, so it is easy to make a mistake. So what is the correct answer?
5,400.
5,400. Do we have this one here? So we have done a mistake? Let's check. We factorize this one correct? Yes. Do we have done this one correct? Yes. So we get 3 to the power 3, 5 to the power 2, 2 to the power 3. So this number, I don't know what's the mistake here, but GCF is 9. What's the mistake here? Can we check, please? Why you have two different numbers here? What is the value here? 2 to the power 3 is 8. 8 times 5 to the power 2 is 400. 400 times 27 is equal to what? Anyway, this is the way how to do it. Maybe it is a mistake we did in notes here. Okay. We'll check. At least now you know how to find the greatest common factor. For this one, this is the algebraic expression. As I told you from the beginning, in the algebraic expression, you have to catch the word. I have 8 times. What does it mean 8 times? It means 8 multiplied by this number. 8 times, it means you multiply. 8 times the sum. So I have to add the sum of what? Of the number and 7. After is the result. So is equivalent to equal 6, right? So this is exactly the correct algebraic model. So the right answer is 1. Okay. For the next one, what is the right answer here? Which of the following is null set? Null set, it means has nothing. X is an integer between -8 and -2. No, we have numbers here. We have something here. It's not null. Okay. X is natural number less than 0. Do we have any natural number less than 0? No, because natural numbers start with 1, 2, 3, 4. So this is nothing inside B, right? So this is the correct answer. For C, X is natural number greater than 2. We have 3, 4, 5, 7. We have infinite number of this. X is an integer less than or equal to 2. It means you have too many things. So the only one doesn't have anything is B, right? Now, how to translate this one into algebraic? 20 less. 20 less, it means what? It means you subtract this number. 20 less, it means this 20 subtracted from what? From the number, right? Okay. So X twice the number. The word twice, it means 2X less than 20 less. 20 less, it means you subtract. 20 more, you add it, right? This is what I mentioned here. So 2x minus 20 is the correct answer. Now, I'll go for this one. I call this one the mixed, right? Yeah, I know. So this mixed number, how to get this one as a fraction? You multiply this one by this one, you have 18. You add this one to this one, you have 19. So you have 19 over 2. If you divide this one, you will have this number. This is how to do this one. So the right answer is A. Now, let's go for each statement, decide if it is true or false. Okay. Where is the statement? Can you see the question? I cannot see the question here. I don't know. Oh, yeah. Let's go for this one. Let's see. Is A 567 inside this one? Yes. True, right? But I cannot see A. Let's see. Cannot see A. Okay. But I have to mention something here related to equivalent or equal or something like this. You have two sets. You have notation called NA. NA, the number of elements in A. This is the number of element, the number of element in A. How many elements you have in the set A, right? So if you have two sets with the same number but different elements, like say A having 1, 2, 3, 4, and you have B as X is a natural number, okay? Okay. X greater than or equal to 1 and less than or equal to 4, because this is the same number, right? Add this one. So A is equal to B. But if I have C is X, Y, Z, W, C, the number of element in C is 4. The number of element in A is also 4. So in this case, I'm saying A equivalent to C, right? So the equivalency only that's they have the same number of elements, right? But the equal must be the same number, right? And the same elements, okay? This is the difference between equivalent. So why I'm saying equivalent if have the same number? Say I have X, Y, Z, and W, and in the other side I have 1, 2, 3, 4. So I can match this one with this one. I can map every one to another one here. This is why we call it equivalent. There are two different sets, but they have the same number of elements, so they are equivalent. But if are exactly the same numbers, yeah, if I can reorder this one, 2, 3, 1, 4, the order doesn't make any difference in the set. They're still having the same element, they are equal. But if they have the two different sets have the same number of elements and they are different, they call it equivalent, okay? So in this case, I'm just trying to explain this one. I cannot see the question over here. Now, two statements are true. 0 belongs to D. What is D? D is a natural number less than 7. What is a natural number less than 7? We know them. Less than 7, I have 6, 5, 4, 3, 2, 1. Because I have to stop 1 because there is 0 is not natural number, negative is not natural number. So what is the correct here? 1 belongs to D? Yeah. Okay. 5 belong to D? Yes. So this is the only correct answer. But 0 is not natural from the beginning, right? 7 is not included because he said below, less than 7. If he said less than or equal, yes, I will get D. But he said only less. So be careful with this one. Now, let's go for this one. Compare, yeah, it's easy because I know the real line. In the real line, I know anything to the left. Yeah, so -4 to the left of 2. So -4 is less than this one. Okay, -6 is to the right to -9. So -6 is bigger than -9, right? Any positive is always bigger than any negative. So -4 is less than 2, -6 is bigger than -9. Be careful, this is a negative because we are going to the left. Any positive is always bigger than the negative value. 5 is equal to 5, right? So you can judge that by the real line. Now let's go. This is the prime. Sorry, I forget this one. I'm just saying the prime factorization. We have something called expand form. This expand form, sometimes in the cashier, if you have this number 230819 in the cashier, they have notes with dirham, for example. So they bought this dirham by 9 plus this is 110. So this is exactly 110. So they write it 1 times to the note of 10 plus this is 800. So they write it 8 times 2 notes of 8 notes of 800. 0, so I don't have 1,000, but I have 10,000. How many one note of 10,000? 3. And I have 2. This 2 is 100,000. So 2 times 10 to the power 4. This is how to write this number in. It's because you have, after 3 digits, you have 1,000. And after 3, you have million, but you don't have anything here. This is how to write this one as a expand form. Okay, remember the cashier. In this one, you can write at 10 to the power 0 because I know 10 to the power 0 is 1. This is like putting the notes in the correct slot, right? So what is our correct answer here? For sure, I go for 2 to the power 10 to the power 5. Sorry, I have a mistake here. This is 5, yeah, because. So what's the correct one? 2 times 10, 2 of, because this is 23, 230,000, right? So 200,000 is exactly 2 times 10 to the power 5. So I am between 1 and 5, right? And I have 3 times 10 to the power, count how many digits to the right? 4, 10 to the power 4. So which one is the correct answer? Both of them having 10 to the power 4. And also, I have 0,000, okay? So I shouldn't have, if I have 0, I have 0 times 10 to the power 3, okay? So I don't have any one of the, so this is never be the right one. So the right one is here. And now I have 1 note of 10. I have 8 note of 100 because it is 819. So this is what we call it expand form. Now, if you have B like this one, the set B written in the set builder. Set builder, remember you have inequality, right? You have 2, 3, 4, 5. This is natural number, right? Yes. Or integers, you can say integer. Integer greater than or equal to 2. So the right answer is this one, right? Now, for this one, you have integer between -5 and 0. So what is the integer having between -1, -5 and 0? -5 is not included, but -4 included because you don't have equal with the -5. Okay? And 0 is included. Okay? Find NA. I just tell you NA, N before the set, it means how many elements you have in the set. So you have 5. So the right answer is 5, right? Okay. Now, find the place of the value of 3. It is easy to find the value. I'll show you how to do it. 3, take the 3 and count how many digits and put zeros instead of this digit. So I have 5 digits, right? So the right answer is 3, and you have 50 in front of this one. Yeah, so that's right. What is the value of 3 in the second one? It is easy to go the 3 for the second one. I have 3 in the first place, so I have only 3, right? Okay, but 3 in the third one, it is in the 100 place, right? So it will be 300, okay? You just take your number and replace the digit to the right by zeros. This is an easy way. So I'm catching 3 and replace 5 by 0, 1 by 0, 9 by 0. So I have 4 zeros. So 3 and 4 zeros. Okay. 3 to the right to the 3, I have only 1 digit. So I put only 1 0. This is the easy way to find the value or the place value of any number, right? For this one, yeah, he's saying A union B. A union B, it means both of them. So what do you have? 5, 4, 1, 3, 9. What is 5, 1, 4, 3, 9? It is C. And I'm expecting this one because the union or is the bigger one, right? So it will be C. A and B, what is in common between A and B is only 4. What's 4? The selection B. Okay, here it is. A, what is A? What do you have in A? 4 and 5, right? So the correct answer is also A, okay? B minus A. B, to take A from B, you take only the common element between them. So you'll take only 4. So what's left with B? 139. 139 is the selection B, okay? Now, yes, you have, there are 6 new books and 5 used book on shelf. What is the ratio? Ratio, it means you have to know the ratio between what? He's asking you what is the ratio of new book? New book, how many new book? 6 books, right? 2, I said you just make this 2 dots, or you make this rational values, right? In the numerator. So 6, 2 to what? All box. How many books I have? I have 6. All box will be 11, right? So 6 to 11. You can write it like this, or you can write it 6 to 11. Okay, so the right answer is this one. Remember, you are not going to compare the old with the new. No, you compare the new to the total. So you have to add them together, right? Number 17. Yes, here it is. You notice I'm using the scratch paper, right? So in the exam, please use the scratch paper. There are 8 roses and 6 daisies in vase. What is the ratio of daisies? Daisies, how many daisies you have? This is 6, right? 2, this is what I said. Or you write 6 and this one. To what? All flowers. All flowers, so I have to add what I have given. So I have 8 plus 6, which is 14. So 6 over 14. You don't have this answer in the choice, right? This is the improper fraction, as I said. Why it is improper? You said the numerator is less than the numerator. That's okay. But still, you can simplify this one. If you divide it by 2, you have 3 and 7. This is a proper fraction. And this is the right answer here. So be careful with this one. Now, yeah, now you have 2 sets and you would like to have and. And is a common element, right? So you catch this one and take the common. What is common between A and B is only, they are the same, right? Yeah, the same, but the order is different. They are equivalent or equal. They are equal because they have the same number with a different order. Doesn't matter, right? So this is equal sets. Okay, what about the second one? The second one, you have x is an integer between -1, so minus or equal -1. So -1 is included, 0 is included, 2, but 3 is not included because you don't have equal in this one. Okay. This one, you compare this one and you compare this one, -1, 0, 1, 2, 3. They are not equal. This one is a subset of this one, right? So they are not equal. They are not equivalent. So this is, I can choose neither, right? For the last one, I have 4 elements here and 4 elements here. Yes, they are different because E, F, G, H's are different from A, B, C, D, but they still have the same number. This is what I told you. If they have the same number but different, you can match them. Yes, you have E, F, G, H, and you have here A, B, C, D. The same numbers you can match one by one, every one with one. This is why they call it equivalent, right? So the same number of elements, but they are different. You take equivalent sets. Okay. Now, what I'm going to do now, I'm just having the complement, right? How to find the complement? As I told you, you just subtract A complement is exactly U minus A. So take A from U. So you will take B and R. So what's left? X, Y, Z, right? X, Y, Z. So what is X, Y, Z over here? If you take A from U, you take P and R. So you left with R, X, Y, Z. Do we have R, X, Y, Z? No, we don't. I think Q, X, Y, Z. Sorry, I didn't notice this. So the right answer is A dash is Q, X, Y, Z. Now for B dash, you take B from U. Yes, I know. You will take what's in common between B and the universal set. So you'll take Q and you will take R and X, Y, Z. Left with B, right? What is the answer here? B is B. C dash, you take C from the universal set. So you will take from U B, Y, Z. B, Y, Z. So you're left over with Q, R, X. Q, R, X is a C. Okay? This is how to find A dash or the complement. In this case, how to check this one are equal or not equal, right? You just make the cross product, you know. If how to check this one, 4 over 5 is equivalent to 12 over 15, you make the cross. If 4 times 12 equal to 5 times 12, it will be equivalent. No, this is 48, but this is 60. So they are not equal. So this is false, right? Okay. Are you okay? No, I make a mistake here. I multiply 4 by 12, but it's supposed to be 4 times 15. Yes, I have done it in purpose, to be honest. 4 times 15 will be 16. Okay, and 4 times 15 is 16, and 5 times 12 is also 16, right? So be careful with this one. So to check 4 over 5 equivalent to 12 over 15, you have to make the cross. You multiply 5 by 12, and you multiply 4 by 15. Don't be in a hurry, because I have done this one in purpose to check. So you will choose the incorrect answer. So they are equivalent. So you, yes, true. Now, this is what I call it, yes, prime factorization, right? How to do the prime factorization? Take your number, 3, 7, 8. It's easy to do this one. This is even number. Use your calculator to divide it by 2. Okay? 3, 2, 7. If it divided by 2, 2 and have 8, 1, 9. Can you divide it with this one by 2? For sure not. Can you divide it by 3? No. Okay? 3, 7, 8. Can you divide it by 2? This is, sorry, I make a mistake here also. When you divide it by 2, this one will be what? Yes, 1, 8, 9, right? Now you can divide it by 3 because this is not even number. But if you add these two together, 3 together, you will have 18. So you can divide it by 3. So I have 6, 3. Now also 3. Now you can divide it also by 3. Now 7, right? So this will be how many 2? 2 to the power 1. 3, how many 3? 3 to the power 3 times 7 to the power 1. Okay? For sure, when I'm going to use the prime factorization, I will never think about the second one and the third one, because it's not acceptable to have something is not prime, like 21 or 9. So you exclude the choice number 2 and 3. So you are between the first one and the second one. Okay? So you have 2 to the power 1, 3 And also, you are not going to take the last one because you have 6. In the prime factorization, without doing this one, I can get the right answer from here. So the last 3 are not correct. So my choice, without doing this one, I can choose the first one because the second one is not acceptable because it has 21, which is not prime. The second one is not acceptable because it is not prime. 9 is not prime. And also 6 is not prime. So without going through those details, you can choose the correct answer, which is the first one. Okay. Now, classify L. Yeah, I didn't mention this one when I'm talking about the fraction. Okay, decimal expansion. You have something called terminating. Terminating, it means you stop at some point, right? So if you have 3 over 5, you know this is 0.6, nothing else, right? But when you have 10 over 3, you will have, or sorry, make it proper fraction. 3 over 10, it is, sorry, 1 over 3. Just take through. If you divided 1 over 3, 1 over 3, you have 0.3, and you will never stop with the 3, right? Sometimes you call it the rounding number here, 3, and you make it. I think I mentioned this one, right? So yes, this is rational, but if they call it recursive. Terminating, it means your decimal will stop at somehow. Okay, but the recursing is you never stop with you repeating the same number. But remember, sometimes you have at the end something different, so this will be terminating. But if after the decimal places everything is repeated, so if you do this one, you have 1.2 by the calculator, so it is terminating. If you do this one, you have 1.6 by the calculator, so it is terminating. Terminating, it means stop at somehow. 14 over 11, can you do it, please? 14.11, what do you have by the calculator? 14 over 11. What do you have? Hello? I know, 1 point what? Do you have calculator? You don't have calculator? Okay, I can use here calculator if you like.
1.272727 then 3.
But
It's recurring.
The end here you have 4, right?
3.
3, right? So this is repeated, yes, but at the end you have something different. So this is not recurring, right? If you have 1.272727, all of this one. But you said at the end you have 3, right?
Yes.
So this is terminating. Yes, you get confused because you have repeated. No, you have to look at the end, right? So this is also terminating, right? Can you do 1 over 3? You will find you will never stop 1.3333, right? But in this case, yeah, it is very confusing. You are in a hurry. You just look in the beginning and you don't notice the end. If the end is different, so it is terminating, right? I almost finished. Now, yes, this is the algebraic expression. How to do this algebraic expression? 9 years older. I told you older than and have a number. So this number will be added, right? Added to what? TAFE. So TAFE plus 9 equal to what? Equal to Hamad, right? Okay. So what is TAFE age if the sum of their age is 81? He's looking for TAFE. So I move this one to Hamad. So Hamad minus 9 will equal to TAFE, right? But the sum of them is 81. So if I subtract I have 81 as Taif and Hamad, right? But I have Hamad is 9 years old, so Hamad will equal to Taif plus 9. So I have two choices here, right? I can replace, I'm looking for Taif, so I replace Hamad here, right? I replace Hamad by Taif plus 9, right? Taif plus 9, okay? So I have Taif and Taif, so I have 2 times of Taif age plus 9 equal to 81. I get this one to the other side, so I have 2 Taif equal to 81 minus 9, which is what? 81 is 72. Now I'm looking for Taif, so I divide it by 2. So Taif will be 36. Once I know Taif is 36, I add 9 to have Hamad because I know Hamad is 9 orders. So if this is 36, and this one will be 45 because Hamad is older than Taif by 9 years, right? Now I'll go for this one. I have the universal set is U, B and C are given. B union C, if I add B union C, so I take everything with B and C, but the repeated one, P and Z, I'm not going to repeat it again. So I have only R extra with B. So I have HP, R, Y, Z. HP, R, Y, Z is number B, right? Okay. Now A and B, what is in common, B and C? What's in common between B and C? I just mentioned now, B and Z, right? What is B and Z? Is the selection C. B minus C, I take what is in common between B and C from B, right? So I take B, no R, I take B and Z. So I left over with B minus C as H and Y. So this is the selection D. C minus B, I'll make the opposite. What is in B? I can take it from C. I can take only B and Z. So I left over with R. R is the choice number A. Okay. Now, classify the number below rational or irrational. For sure, this is rational because this is fraction. Yeah, don't go for the root unless you check. Root square 16 is 4. 4 is rational because you don't have decimal, right? Once I see by, I go for irrational without thinking. Root square 5, if I do it by the calculator, I will have 2 point something. Once I have point something, it means irrational, right? Okay. Now, twice sum. Twice, what does it mean twice? It means 2 times. The sum, it means something added to the something. 7 plus the number is mean equal, right? 40, right? This is the right expression. Find the number is x. So what I'm going to do, use the distribution law. So you have 14 plus 2x equal to 40. Now I'm looking for x. So move this one to the other side. 2x is equal to 40 minus 14, which is 36, divided by 2. You have x equal to what? 80. So the right answer, sorry, did I make a mistake? It's 40. Twice the sum of number and 7, x plus 7 twice is equal to 40. Yes, I'm correct. 2 times 7 is 14 plus 2x. 40 minus 14 is not 30x, it's 26. This is my mistake. So 26 by 2 is 30. So be careful when you are doing this one, okay? Sometimes I make the mistake in purpose, just everyone makes mistakes, okay? So you have to recheck, you still have time. Now, identify the set below as a finite or infinite. Once you don't have dots to the right or to the left, you are not infinite. The dot in the middle, no, you still finite, but instead of writing the whole thing, he just make dots just to carry on. So this is finite. X greater than plus 6. I know x greater than or equal to 6. I have 6 here, square bracket, and I have everything until I reach finite, infinite. So I know this is infinite. Set of all multiple of 5. If multiple of 5, and cannot, multiple of 5 is 5, 5 squared, 5 to the power 3, okay? I don't know what's that. So 5, 5, 2, this is, sorry, I'm sorry. Multiple of 5 is 5, 10, 15, 20, etc. So you have infinite number of multiple, okay? But the number of students in all HCG campuses is still finite, right? For this one, yeah, how to solve this one? The cross product we used to do, 3 over y minus 2 equal 2 over y minus 5. Just make the cross product. So you multiply the 3 with y minus 5, and you multiply 2 by y minus 2. Use the distribution law. 2y minus 4 will equal to 3y minus 15. Okay. Now, get y with y, and take the number with the number. So what do you have? You have 3y, and you move the positive 2y to the other side and you go the number, and you have minus 4 in the right hand side. When you move the 15, it was minus. So when you move it to the other side, it will be positive. Now, how many y? You have only y. How many? This value is 11. Sorry, is 11. So y is equal to 11. This is the right one. Now, check whether the number below is integer or not. Not minus 9. It is an integer, right? 16 over 3. You will have decimal, right? When you have a decimal, it is not integer. Integer, you shouldn't have anything after the decimal point, right? So this is not integer. This is very clear, it's not integer because it has decimal. Minus 12 over 6 is equal to minus 2. So don't go and just say, no, this is not. No, this is integer. You can divide it minus 12 over 6 to have minus 2, which is integer. The last one to say bye-bye for you. Now, yeah, what do you need here? You need to graph something, right? You have a drug trial, 238 participants. So in total, how many one you have in total? 238. That's fine. You have how many? Information about this experience by participant. 105 participants reported they flat drowsiness. So the drowsiness is 105. So inside this total, I have drowsiness. I call it D, just to make it easy. How many? 105. Okay. And the other one reported reported experience anxiety. Anxiety, let's call it A, just to make it easy. Anxiety, let's call it A. Anxiety, call it A. How many one in A? 184. 184. 184. Let's make this one outside. 105. And how many? And 7 reported they had both. So in common, they have 75 over here. In common, they have 75, right? So what is left outside here is 105 minus 75. What is left here is 184 minus 75. So how much is this one? 30. How much is this one? 184 minus 75 give you what? 109?
14.
100?
14.
No, this is 4. This is not 9. This is 184 minus 75.
109.
Yeah, 109. So let's go for the question. How many participants had only an anxiety? Only an anxiety, it means they don't have in common things, right? So only an anxiety. What is only an anxiety will be here, right? How many do you have here? 109, right? Because they have only an anxiety. 109, okay? How many participants had an anxiety or drowsiness? Or it means it will be here, or here, or here, right? So I'm going to add 30 plus 75, which is 105, plus 109. So 105 plus 109. So how much it will be? 214, right? Oh, 214, okay. How many participants didn't experience an anxiety or drowsiness? So it means I have to get any outside this one, they have no problem. So this is how much is this one? Okay. I know the total is 240 inside here and in common. So I get the total 238 minus 114, which have an anxiety and drowsiness, right? So what is the value here? $24. So this is 24. Now I can submit. Without using your scratch paper, you will be in trouble and choose a correct answer. Without using your calculator in the correct way, also you have a wrong answer. Now I can say thank you for watching me, and now you can do your trial for review CLO. It is already open all the time, so you can repeat it if you have a mistake, okay? But again and again, without the knowledge, don't go to solve any question. Thank you. Assalamu alaikum.